lesson 3.7. We are on page 231 and we are learning how to divide decimals by whole numbers. Our Common Core State Standard is that we will be able to fluently add, subtract, multiply, and divide multi-digit decimals using the standard algorithm. So we are using the standard algorithm of long division. We learned a lot of other really great methods to help us to build our mathematical foundation in elementary school, and now we're using those to help us with the standard algorithm for division. So we're going to get right into our lesson on page 232. And we are learning how to divide a decimal by a one-digit number. When we are dividing a decimal by a whole number, divide as with whole numbers. So we do this division algorithm the same way that we always have. And the only thing that's different is that we will take that decimal point from the number that's being divided and move it directly up into the dividend. So let's go ahead and look at example 1 together. We have 6.8 divided by 2. So we will, first of all, we have that visual aid. You have 6.8. If you're dividing that by 2, so you'll have 2 individual pieces. What's half of 6? 3. So you would have 3 here and 3 here. And what's half of 8/10? 4/10. So you would have 4/10 here and 4/10 here. So that's pretty straightforward. It doesn't require us to do any regrouping or borrowing or anything like that. So just a concept. You just take each of those and divide it, each of those digits and divide it by 2. So it's not always going to be quite that straightforward, but let's go ahead and do the algorithm with this nice example. So if we have 6.8 divided by 2, okay, we divide like normal and we bring our decimals straight up. Okay, so then that's all we need to do with the decimal. Everything else is the same as we've always done since 5th grade. So what is 6 divided by 2? 3. 3 times 2 is 6. Okay, 6 minus 6 is 0, and then we bring down the 8. 8 divided by 2 is 4. 4 times 2 is 8. We subtract and we get 0. So our answer is 3.4. Let's look at example A. We have 7.5 divided by 3, and I'm going to use this workspace right up here. 7.5 divided by 3. And notice I always like to skip a line because I know I need my quotient to be in the top there. So 7.5 divided by 3. My first step is to bring that decimal straight up. Okay, then we divide like normal. Does 3 go into 7? Yes. How many times? 2 times. 2 times 3 is 6. Then we subtract. 7 minus 6 is 1. Great, that's less than 3. And then we bring down our 5. 3 goes into 15 5 times. 5 times 3 is 15. We subtract and get 0. So we have 0 here and we don't have any more numbers to bring down, so we know we're finished with that problem. So our answer is 2.5. All right, let's do example B. We have 3.5 divided by 7. 3.5 divided by 7. I'm going to work right here. So remember, we want to bring our decimals straight up, and then we divide like normal. Does 7 go into 3? No, it does not. So, well, this is slightly different than normal because if it didn't go into 3, if it were 35 instead of 3.5, we would just put nothing here. But since we have the decimal, we do need to have a 0 before the decimal. So does 7 go into 3? No. So we can't put anything above 3 except for the 0. It doesn't go in any times. It goes in 0 times. Then does 7 go into 35? Yes, it does. It goes in 5 times. 5 times 7 is 35. And then we have 0 as a remainder, which is great. It goes in evenly, and we don't have any other numbers to bring down. So our answer is just 0.5. Example C, we have 9.8 divided by 2, And I think I have enough room to put this in here if I write small. Otherwise, you can find some empty space in your book. I'm going to save the space at the bottom for the second example. So letter C, we have 9.8 divided by 2. We bring our decimal straight up. Does 2 go into 9? Yes, it does. How many times does it go in? 4. 4 times 2 is 8. 9 minus 8 is 1. Bring down the 8. How many times does 2 go into 18? It goes in 9 times. 9 times 2 is 18. Subtract, we get 0, and there's nothing else to bring down. So our answer is 4.9. Okay, so that was dividing a decimal by a one-digit number. Now let's just bump it up one more step of difficulty. We're going to divide a decimal by a two-digit number. So let's go ahead and look at this section. Let's adjust the camera. The decimal point in the quotient is placed directly above its place in the dividend. In real-world solutions where the division does not result in a remainder of 0, round the quotient to a specified place. So they'll tell you which place value to round to. We in 6th grade are just going to mostly round to the 10th place, so just one decimal. By the time you leave in 8th grade, when you leave middle school, you'll be consistently rounding to 2 decimal places. That's a little bit more precise. So here we have 7.7 divided by 14. So we go ahead, this one's actually done for us. 7.7 divided by 14. Let's work it out here just so you can kind of see the steps walking through them. So 7.7 divided by 14. So first of all, we are always going to just bring that decimal straight up. Okay, does 14 go into 7? No, it does not. So above the 7, I'm just going to write a 0. Does it go into 77? Yes, it does. So 14 is pretty close to 15, and I can count by 15s pretty easily just by, adding 10 and then adding 5 each time, or counting by 30s and then every other time adding 15. So a couple different strategies for that. So if I'm estimating, so 15, 30, 45, 60, 75. So that would give me 5 times. So I'm just rounding. Those are my compatible numbers. Okay, so 15, that's a compatible number. I can estimate how many times that'll go into 77. And my estimate is 5 times. 5 times 4 is 20. I write the 0, carry the 2. 5 times 1 is 5, plus the 2 I carried is 70. So then I subtract. 77 minus 70 is 7. Now I don't have any digits to bring down, so I want to annex a 0. So put a 0 here, put a 0 here, and then bring it down. And then I already had a 70 here exactly with this 5, so I don't have to really think about that. I can just know that that's going to be a 5 again. So I already did 14 times 5 and I got 70. So I'm just going to write that down. 70 minus 70 is 0. So then I know I'm done with my division problem. So my answer is 0.55. All right, so let's do some examples on page 233. All right, letter D. We have 9.48 divided by 15. We'll work right here. I'm going to leave a little space for my answer. 9.48 divided by 15. And I'm just going to bring that decimal straight up. Does 15 go into 9? No, it does not. So above the 9, I'm just going to write a 0. Okay, and then I'm going to count by 15. So 15, 30, 45, 60, 75, 90. So I'm just adding 10 and then adding 5 in my head each time. So that's 6. And I just counted that out. So I know 6 times 15 is 90. I don't need to do it again. 94 minus 90 is 4. and that's less than 15, so it's a double check to make I know I did that correctly. That division, that 6 is correct. And then I'm going to bring down an 8. And then how many times does 15 go into 48? Well, 15, 30, 45. So it goes in 3 times. 3 times 15 is 45. We just counted that out. 48 minus 45 is 3. Did they tell us which around to? Mostly in our homework today, and I want to point this out now, and I'll remind you at the end of the lesson as well. Most of your homework problems, this is really important. It's going to save you some time on your homework. So you definitely want to hear this direction. Round to the nearest tenth. Okay, because some of these answers will just keep going and going and going, and they'll have like 6 and 7 and 8 and 9 steps, and we don't want you to do that. We really just want to do 2 steps and then round that to maybe 3, depending on how big the whole number is, and then round that to the nearest tenth. Okay, so please follow these directions. Otherwise, your homework is going to take you way longer than I want it to. So we're just rounding to the 10th, which means you need to divide to the 100th place so that you can round down to the, or round to the 10th place. So we'll do that in this example. So I don't need to continue on. I don't need to annex a 0 and bring it down. I could, all right, but I have enough here that I could round to the nearest tenths, or to the nearest tenth. But let's go ahead and do this since we're almost all the way there anyway. So how many times does 15 go into 30? It goes in twice. 2 times 15 is 30. Subtract, we get 0, and there's nothing else to bring down. So we're finished with this answer. It's 0.632. And then how do we read this number? So first of all, when we read this number, it's a 0. So we don't need to say 0 and. We just read the numbers after the decimal as if they were a whole number. So pretend for a moment that's a whole number. You would say 632. Then you say the place value. This is tenths place, this is the hundredths place, this is the thousandths place. So how do we correctly read this number? We say 632 thousandths. Okay, you can also say 0.632. But it's going to help you to start becoming familiar with the place value. So this is 10, right? So think of a 1 followed by a 0, tenths place. This is the hundredths place, the 3. So think of a 1 followed by 2 zeros, right? This is a 10 has 1 0. That's the tenths place. It's the first decimal place. Okay, 1 0, first decimal place. A number 1 followed by 1 0 is the tenths place. This is the second decimal place. It's called the hundredths, right? It's a 1 followed by 2 zeros. How do you read a number that's 1 followed by 2 zeros? 100, right? So how do you read it as a decimal? Hundredths, okay, or 100ths. And then this is the thousandths place, right? Third place, third decimal. What's a 1 followed by 3 zeros? It's 1,000, okay? So this is the thousandths place. Hundredths, tenths. Okay, so that's just a little refresher about place value. Then let's go ahead on to problem E. We have 3.49 divided by 4. Okay, so I don't have a ton of space. I'm going to see if we can do this one here. I'm going to write a little smaller. .49 divided by 4. Okay, so then I'm going to take my decimal and bring it straight up. Does 4 go? Oh, I'm off the camera. I'm so sorry. So go ahead and write that down. 3.49 divided by 4. Bring your decimal straight up. And then does 3 go into 4? No, it does not. So we put a 0. Does 3 go into, does 4 go into 34? Yes, it does. I know 8 times 4 is 32, so that's a very good estimate. 8 times 4 is 32. Then we subtract. 34 minus 32 is 2. And then we bring down the 9. 4 goes into 29 7 times. 7 times 4 is 28. Then we subtract again. 29 minus 28 is 1. Now we need to annex a 0, bring it down. How many times does 4 go into 10? Twice. Okay, so put a 2 here. 2 times 4 is 8, and then we subtract 10 minus, and we would not go this far in our homework, okay, because on our homework, it just has us rounding to the 10th. So we would say 0 point, and then we look at this 8, say, is the number after that 5 or higher? Yes, so the 8 gets rounded up to a 9, and our answer would be approximately 0.9, so approximately 9/10. But let's go ahead and finish this just for fun, okay? So 10 minus 8 is 2, okay? 2 is less than 4, so that's good. Annex another 0, bring it down, okay? How many times does 4 go into 20? 5. 5 times 4 is 20. Okay, so that checks out. 0.8725, that was letter E. Okay, and again, on your homework, you would not do that many steps. You're just going to round to the nearest 10th. So you would just need to have typically 2 rows of division, okay? Unless we have a whole number there, you may have to do 3 rows. All right. Example F, we have 55.08 divided by 17. I think this one's all worked out for you. Number 3 is all worked out for you, so you can read this and you can go right through the whole problem. I'm just going to use this space to do example F. $55.08 divided by 17. I bring my decimal straight up. 17 is pretty close to 15, and I can count by 15s pretty easily by doing plus 10 and plus 5. So 15, 30, 45, okay, that's 3 times. 60 would be too big, so it just goes in 3 times. So 17 can go into 55 3 times. 3 times 7 is 21. Again, 3 times 7 is 21. Write the 1, carry the 2. 3 times 1 is 3, plus the 2 we carried is 5. 51 is, that we subtract. 55 minus 51 is 4. 4 is less than 17. I'm just going to erase that 2 that I carried in case it's caught, so it doesn't cause any confusion later. So then we bring down the 0. Okay, again, 17. We already did 17 times 3 is 51, so we know that's going to be a little bit too big, so we can go ahead and do a 2. Okay, 2 times 7 is 14, write the 4, carry the 1. 2 times 1 is 2, plus the 1 we carried is 3. 40 minus 34 is 6, and then that's less than 17, so we're in good shape. Then we bring down the 8, okay, and again, we're going to use compatible numbers. Okay, so how many times would 15 go into 68? Okay, so let's estimate 15, 30, 45, 60. So 4 times, because the 5th number would be 75. That'd be too big, so 4 times. 4 times 7 is 28. Write the 8, carry the 2. 4 times 1 is 4, plus the 2 we carried is 6. So we get 68, and we're done. So letter F is 3.24. Okay, let's do a word problem. And again, this is done for you, and we actually have a similar problem on the guided practice that we'll do that's similar to the cost per pound. Okay, so let's look at letter G. Find the cost per pound of that's the problem I was thinking of, the cost per pound of a 2-pound and a 4-pound package. Okay, so a 2-pound package and also a 4-pound package. So this is a 2-part problem. So we are going to mail a package. If the package weighed 2 pounds, the cost was $5.63. Okay? And they're really helpful in the problem. If you read the problem carefully, they actually give you the instructions in the problem of what to divide by what. So which number gets divided by which number. So when it tells us find the what? Find the cost per pound, okay? So they're really giving you the directions for getting the answer right there. Cost per pound. So this means we're going to be looking at our price in dollars per, and that's the division sign, okay, or fraction bar, pound. Okay, so it's dollars divided by pounds. Dollars divided by, remember that's the division bar, divided by pound, right? So think of the fraction 1/2. This means 1 divided by 2, right? What is 1 divided by 2? That's 0.5, half, half. Okay, this is 1 divided by 2, all right? Sometimes kids get confused. I forgot which one should go in the box. Go back to your basic example. Go back to 1/2, right? You know that 1/2 is 1/2. Okay, you know how to do that problem. So if you ever get confused, go back to a simpler problem and then follow that same pattern for your more difficult problem. You know how to do this, okay? So 1 divided by 2 would be like this, 1 divided by 2. Does 2 go into 1? No. So I put a 0 above the 1, put a decimal that I bring straight up, and then I annex a 0. Does 2 go into 10? Yes, it does. How many times? It goes in 5 times. 5 times 2 is 10, and we subtract, we get 0. Okay, so 1 divided by 2 is half. That's how it works out. That's just a little sample problem that you can always call back on, right? Even let's say you're in 8th grade and you're used to using a calculator all the time, and then suddenly you're taking your PSAT class prep and you need a little refresher. Always go back to a simpler example and use that to help you do a more difficult problem. Okay, so cost per pound is always going to be dollars per pound. So 2-pound package, so where does the 2 go? It goes in the denominator. And how much did that 2-pound package cost? I look at the table, $5.63. So this is going to be $5.63 divided by 2. So I'm going to squeeze that in way down here. I'm going to adjust the camera. Okay. I think I'll have to do it here. I don't think that's quite enough space. Okay, I bring my decimal straight up. Does 2 go into 5? Yes, it does. It goes in 2 times. 2 times 2 is 4, and then I subtract. 5 minus 4 is 1. Bring down the 6. 2 goes into 16, 8 times. 8 times 2 is 16. Bring down the 3. 2 goes into 3 1 time. 1 times 2 is 2. I subtract and I have a 1. Bring down a 0. 2 goes into 10 5 times. So it's $2.815 per pound. So $2.815 per pound, except we wouldn't say $2.81.5, right? We would say $2.80 what cents. Well, look at the number. Here's our 1. The number after it, is it a 5 or higher? Yes, it is. So we would round this to $2.82. Okay, so 2 pounds. Okay, the price per pound is, so 2 pounds at $2.82 per pound. Okay, and then let's do the same thing for our 4-pound package. Our 4-pound package is $7.87. So we want to find the price per pound. Let's see if I can zoom in a little bit. Oh, wow, yeah. Okay. So 7.87 divided by 4. Sorry, I'm adjusting the camera here, getting used to this camera. 7.87 divided by 4, it's dollars per pound. So 7.87 is the dollars divided by 4. Bring your decimal straight up. Now, I did say that we typically will be rounding to the nearest tenths place, but when we're talking about money, we always round to the hundredths place because we use pennies as our smallest denomination when we're talking about money. So anytime we're dealing with money, you need to understand they're expecting you to go to the nearest hundredths place because that's where the penny goes. Okay, so we have 7.87, yeah. Okay, so let's go ahead and divide that out. Does 4 go into 7? Yes, it does. It goes in 1 time. 1 times 4 is 4. Then we subtract. We get 3. Bring down our 8. This goes in 9 times. 9 times 4 is 36. Then we subtract. 38 minus 36 is 2. We already brought down the 8, so we need to bring down the 7. Okay. 4 goes into 27. 6 times 4 is 24. Subtract, and we get 3. Bring down a 0 here. Annex a 0 to bring it down. Okay, and then 4 goes into 37 times, because 7 times 4 is 28. Okay, that gives us 2. And I can stop there because I went off the table a little bit. Let's get that on the screen. I can stop there because I have 1.967. And when I'm talking about money, okay, I'm just going to say either $1.96 or $1.97. So I look at this, the penny, the place value for the hundredths. Look at the number after it. Is it 5 or higher? Yes, it is. So we round it up. So this will not be $1.96. It'll be $1.97. So 4 pounds would cost $1.97 per pound. Okay, so that's our answer to the price per pound when we buy 2 pounds, and the price per pound when we buy, or when we ship. These are shipping costs when we ship 4 pounds. Okay. All right, page 234. Ryan and his brother are sharing the cost of a video game. The video game costs $28.60. If Ryan saved $20 to buy the game, how much does he have left after paying his share? Okay, so first of all, the game is $28.60. So we divide it by 2. What's half of 28? 14. What's half of 60? 30. So $14.30 per brother. Okay, so the brothers are each going to pay $14.30. And then it says, how much will Ryan have left after paying his share? He has saved $20. So we're doing 20 minus his share, so $14.30. So what I do in my mind is I round that up to 15, which is not 15, but I know from 15 to 20 is $5. Okay, but it wasn't $15. It was 70 cents less than $15, so I have $5.70. So instead of subtracting it, I just counted up. Okay, and people do that when they count their change back to your change back to you, right? If you paid with $20 and your total cost was $14.30, they first give you the change, the 70 cents. Okay, and that brings that $14.30 up to $15. So they'll say, and 70 cents makes 15, and then they give you the next $5 to bring it up to 20. So that's what cashiers typically do, just kind of to let you know they're giving you the correct amount of change. Although it's becoming less and less prevalent these days. All right, then we've already done enough word problems. Let's go ahead to some guided practice. And we'll see if we can zoom in a little bit. Excellent. All right, number 1 on the guided practice, we're on page 234. Now remember, we're going to really carefully follow our directions. We don't want to make our homework too tedious, so we're rounding to the nearest tenths place. So we have 3.6 divided by 4. Okay, 3.6 divided by 4. We bring our decimals straight up. Does 4 go into 3? No, it does not. So above the 3, I write a 0. Does 4 go into 36? Yes, it does. It goes in 9 times. 9 times 4 is 36. We're finished. We have nothing left. We have 0, and we have nothing to bring down. So our answer is 9/10. Okay, number 2. We have 12.32 divided by 22. Bring your decimal straight up. Okay, does 22 go into 1? No, it does not. Does it go into 12? No, it does not. Does it go into 123? Yes, it does. So if I estimate, I'm thinking of compatible numbers. Okay, we did a lesson on compatible numbers to help us with estimating here. And remember, estimates are just estimates. We won't always get them correct, okay, but they'll get us close, and then we can zoom in on where we need to be. So I'm going to look at 22 and I look at 123, and for compatibility, I think of 20 and 120. That would go in 6 times, right? Because 6 goes into 12, or excuse me, because 2 goes into 12 6 times. But this is 22, and I'm rounding that up times 6. This is only 123. It's only getting rounded down once. Okay, so 6 will probably be too big. I'm going to probably have a 5 here. And remember, if you're unsure and you don't want to have to erase in your problem, you can always work that off over to the side, right? You could do 22 times 5 and see if it's too small or too big. You can do 22 times 6. I'm just going to do it right here in the problem, but you can definitely always feel free to write that off to the side, okay? I will see your work and it'll be great. So 5 times 2 is 10. Write the 0, carry the 1. 5 times 2 is 10, plus the 1 we carried is 11. And then we subtract. 3 minus 0 is 3. 2 minus 1 is 1. Okay, 13 is less than 22, so we divided correctly with the 5. That was correct. And if it weren't correct, we would just erase it and try again. Don't get frustrated. You're not going to get it perfectly right every time, okay? And then they're telling me to round to the nearest tenth. So even if this doesn't work out properly, I can, once I have this number and I know that this number is correct, I can stop and know what to round that to the nearest tenth. Okay, so remember, reading the directions can save you a lot of frustration and extra work. So bring down the 2. So we have, let's see, I'm going to try a 6 here. So I'm going to round this down to 20, round this down to 120, and try a 6. 6 times 2 is 20, or 6 times 2 is 12. Write the 2, carry the 1. 6 times 2 is 12, plus the 1 we carried is 13. That's perfect. Okay, so 0.56. But our directions told us to round to the nearest tenth. So then I look at the number after the 5, because this is my tenths place. Look at the number after it. It's a 6. Is that 5 or higher? Yes, it is. So we round our 5 up to a 6. So this is 0.6. Okay, by rounding to the nearest tenth. All right, and here's another one. It looks like a long one. Remember, we're not going to keep dividing and dividing and dividing and dividing. We're going to round to the nearest tenth. Okay, so let's do that. Number 3, 69.904 divided by 34. I bring my decimal straight up, okay? I'm just doubling this in my mind. I look at the 69, I think compatible numbers, and I think of 68. Okay, I double this, 34 will give me 68. So how many times does 34 go into 69? Twice. Okay, 2 times 4 is 8. 2 times 3 is 6. We're just doubling it. 69 minus 68 is 1. Bring down the 9. Does 34 go into 19? No, it does not. So I write a 0 here and bring down the next digit. Okay, we always want to remember to write the 0. Did it go into 19? No, it did not go into 19. So above that 9, this 9 right here, we write a 0. And then 34, 190, probably going to do a 5 or a 6. Let's see. If I round that to 30, 30 times 5 would be 150. 6 would be 180, but this is a 4. I'm going to try a 5. It might be a 6, but let's try a 5. 5 times 4 is 20. Write the 0, carry the 2. 5 times 3 is 15, plus this 2 is 17. Yes, that was good. That was close. 190 minus 170 is 20. 20 is less than 34, so I know this was correct. And then I don't need to keep going. Okay, I don't need to bring down the 4 and then annex a 0 and annex another 0. Stop. Okay, follow the directions. It told us to round to the nearest 10th. For 6th grade, that's all we're doing. This is part of knowing the algorithm, like what degree, how precise do you need to be? Well, for now, we're just going to the nearest 10th. So we do not need to keep going and going and going all the way until we're finished. Okay, and that's really important to know for your homework because some of the problems on your homework are going to have you going multiple decimal places. And I don't want you to get frustrated or wonder why a problem has 12 steps. We're going to stop once we get enough decimal places to round to the nearest 10th, which means we need 2 decimals in our answer. So 2.05, look at the 10th place, it's a 0. The number after it, is it 5 or higher? Yes, it is. So we round it up to 2.1. Number 4, we have a word problem. Light travels 5.88 trillion miles in 1 year. How far will light travel in 1 month? Okay, well, we need to know how many months are in a year. That's 12. So this is, and we'll keep it in trillions of years. We don't need to change that. We don't even need to write that out with zeros. We're going to just keep our unit as trillions, okay? So we will have 5 point, I'm going to try to see if I can fit this in right here. And we're going to steal a little bit of space from this ranking. Okay, with my whiteout. Gotta love the Bic whiteout. It's good stuff. Okay, all right, so that's the good stuff right there. You can write on it immediately. You don't have to wait for it to dry. Okay, so 5.88. We'll write it here. We're going to use that space. Divided by, well, how many months are in a year? 12. Okay, we bring our decimal straight up. Does 12 go into 5? No, it does not. So above the 5, I write a 0. Does 12 go into 58? Yes, it does. 12, 24, 36, 48. 60 is too big, so not 5. It will have to be a 4. We just said 12 times 4 is 48, and then we subtract. 58 minus 48 is 10. Great, that's less than 12, so that's correct. And then we bring down the second 8. So let's see, if I did it 10 times, 12 times 10 would be 120. That's a little too big. So I'm going to try a 9. I think that'll get me really close, if not perfect. 9 times 2 is 18. Write the 8, carry the 1. 9 times 1 is 9, plus the 1 we carried is 108 exactly. So this is 0.49. And remember, they told us to round to the nearest 10th if necessary. And okay, so we did have 2 decimal places. So 0.59 would round to 0.5. So 0.5 trillion miles per month. Okay. All right, number 5. 4 dozen bagels cost $30. How much change will you receive if you pay for a dozen bagels with a $10 bill? Okay, honestly, I would not divide this out with long division. Okay, so I'm going to show you, we've done a lot of long division problems. So let's do a mental math problem with shopping. Okay, so if I'm buying 4 dozen bagels and it's $30, honestly, I'm going to write this, I'm going to steal this space right here on the essential question for number 5 or 6. I'm going to just take that space and use it for our bagel problem. So actually, that's a good question. So we'll squeeze it in here. 4 dozen bagels cost $30. So how much will 1 dozen cost? Okay, so 4 dozen bagels are $30. How much will 1 dozen cost? Well, to get from 4 to 1, I divided by 4, right? Divide by 4. So to get from $30 for 4 dozen to our price per dozen, the same thing, we're dividing by 4. A nice way to divide by 4 is to divide by 2 and then divide by 2 again. So what's 30 divided by 2? 15, and 15 divided by 2, 7.5. So 1 dozen would cost $7.50. And I should have written that the other way around. I should have done dollars per dozen because that's typically how we would say price. But that's okay. It's about the proportion. So 1 dozen bagels cost $7.50. And then how much change would you get if you paid with a $10 bill? Okay, and again, I'm probably not subtracting, I'm probably counting up. Okay, from $7.50 to 8, I add 50 cents, and then from 8 to 10, it's $2, so I would get $2.50 change. Okay, and you don't have to do it that way. I just wanted to kind of give you a way to think through the problem a little differently. And then lastly, building on the essential question, how can estimating quotients help you to place the decimal correctly? Just lets you know if you're in the ballpark. It can help you to know if you have put the decimal in the wrong place, okay? So, and it can help you to know if you have put the decimal in the wrong place. Let's say in the right place. If you've put the decimal in the correct place or the right place. Okay, so that is dividing decimals by whole numbers. So that is Chapter 3, Lesson 7. So basically, we divide like normal, except we bring that decimal straight up. And then when you are doing the division problems, please make sure that you are carefully reading the directions so that you are not doing steps upon steps upon steps of long division. So we're going to have moderately long division. So we're going to be doing long division, but we're not going to do, 7 different rows in that long division problem. So make sure once you have 2 decimal places, so once you're in the hundredths place, that's enough for you to be able to round to the nearest tenth. All right, thank you.